Hello friends, today I will discuss about what is ISF, that is Instrument Security Factor for metering class CT, and what is the relation between ISF and CT burden for metering class CT. So friends, if you go through the nameplate details of the current transformer, then you can find that metering class CT is defined by the parameter instrument security factor, and the metering class, normally metering class is either it is zero point 0.2 or 0.2s or zero point 0.5 or 0.5s. So in this nameplate there are three cores. Now core number one is the metering core, and it has the different tag position. If 1 is 1 and 1 is 2 is taken or selected, it is selected as 400 by 1 CT ratio. If 1 is 1 and 1 is 3 is taken, then it is selected as 800 by 1 CT ratio, and if 1 is 1 and 1 is 4 tab are selected, then CT ratio shall be 1000 by 1. So in case of metering class CT, there are parameter like CT burden in terms of VA, and metering class and instrument security factor is mentioned in the nameplate. So in this video, I will discuss about what is instrument security factor and how it is related with the CT burden. So instrument security factor here is mentioned as less than 5. Instrument security or instrument safety factor is defined as the CT saturation current to the CT rated current. It is the ratio of CT saturation current to the CT rated current. So if it is a 400 by 1 CT ratio, then instrument security factor 5 means if 5 times of the 5 times of the rated current flows in the primary side, then CT will saturate. So let us elaborate with an example that CT ratio is taken as 400 by 1 and instrument security factor is less than 5, under CT burden is 20 VA. So if 400 ampere current flows in the primary side, then 1 ampere current will flows in the CT secondary side. So instrument security factor is 5. So if 5 times of the primary current, that is 5 into 400, which is equal to 2000 ampere or 2 kiloampere. If 2 kiloampere current flows in the primary side, then secondary current shall be 5. So as per nameplate details, that is instrument safety factor or security factor is maximum as 5. So if 5 times of the rated current flows in the primary side under rated burden conditions, that is under CT secondary burden as 20 VA, then CT shall saturate. So what is the purpose of this instrument safety factor? So why ISF is an important parameter for metering class CT? In case of metering class CT, in the CT secondary side, normally metering instrument like ammeter, wattmeters, megahermeter are connected in the CT secondary side. So under normal conditions, the meter shall accurately give the reading of the what is the current is flowing in the CT secondary side, or what is the actual replica of the CT primary current. So the purpose of this instrument security factor is to safeguard the instrument which is connected in the CT secondary side of the CT metering core. For metering class CTs, it is expected that CT shall maintain the required accuracy under normal load conditions. But under fault conditions, since fault may be as high as that is 20 to 30 times of the primary current. So if 30 times of the primary current flows under rated burden conditions, that the CT secondary current, if it is a 400 by 1, then CT secondary current can go up to 30 ampere. So under this high fault current, the instrument which is connected in the CT secondary circuit may damage. So in order to safeguard the instrument security factor is provided for metering class CT. So here ISF less than equal to 5 means if 5 times of the rated currents flows in the primary side, and then CT will saturate under rated burden conditions. If 20 VA is the rated burden, then rated burden in terms of ohm will be 20 ohm under CT's rated current, secondary rated current at 1 ampere. Now, how does the ISF is relate with the CT burden? In case of nameplate, the CT rated burden is mentioned along with the ISF factor, which is less than equal to 5. So, under rated burden conditions, 20 VA. So, this ISF is satisfied under the rated burden or rated load, which is connected in the CT secondary side. So consider the CT ratio is 400 by 1 and rated burden is 20 VA, means rated burden in terms of resistance or load connected in the CT secondary circuit is 20 ohm under rated current, that is 1 ampere. Now consider that ISF is less than equal to 5, that means the saturation voltage Vs will be equal to 20 into 5, which is equal to 100 volt. Now consider that CT actual burden, that is the actual burden which is connected in the CT secondary circuit is 5 VA. So in terms of load in terms of ohms, that is RA is equal to 5 ohm under rated current. So the ISF actual in real case will be vary as per the formula given by Vs is equal to ISF A into RA. So ISF A will be equal to Vs divided by RA, which comes as 100 divided by 5, which is equal to 20. So you can find that although the ISF is less than equal to 5, but in real case, since the actual burden is 5 VA, so if under 5 VA burden conditions, if 20 times of the rated current flows in the CT primary current, and then the CT will saturate, though. So the saturation level is higher under lower level of the burden conditions. So here the instrument security factor are not guaranteed, since the burden which is connected in the CT secondary circuit is much lower. So this is the purpose of the instrument security factor, and it is related with the CT burden, which is mentioned in the nameplate details. So friends, if you like my video, then do subscribe my channel and also press bell button for notification of videos to be uploaded in future. Thank you for watching this video. Thank you.